All right, so far we've looked at linear inequalities and compound inequalities. The next section, we're going to look at compound functions and absolute value function. Now, there was one problem on your worksheet one, which was about compound functions. Many of you got the result correct. Some of you did not, and I wrote comments about how to think about these functions. Um, so let me give you an idea here. Now, you already know what a function does. You send an input, you have the function, and it gives an output. But sometimes what happens is the function itself may not be straightforward and have something going on inside of it. Now, a real life example would be check-in rates for luggage. They vary by how many bags you check in. So I looked some airline up, I don't remember which one, but say the first bag it charges $30, the second one it charges 45, the third one it charges 150, and the fourth one it charges 200. Question is, how much do I pay if I check in three bags? So 30 plus 45 plus 150 is 225. Let's say I want to write a function which tells me, depending on the input, what I'm going to get. So it's like different function that I'm going to use depending on how many number of bags there are. Yeah, if the input is 1, I use 30. If the input is 2, I add 45 to it, and so on. So what's happening here is the behavior of the function depends on the input. Behavior may not be the exact. So even if you maybe skip the word behavior, the function itself depends on the input, right? Such a function is called a compound function. For example, f of x equals 2x when x is between 0 and negative half, 2x minus 1 when x is between 1 half and 1. Now, let's say I want to plot this. Yeah. What's f of 0? F of 0, since the input is 0, that's the definition I use. Because it says when the input is between 0 and half, I use this definition. So f of 0 is 2 times 0, which is 0. So I'm right here. What is f of 1 half? Now, if you look at it, for 1 half, it's not included here. It's included here. So I use this definition. F of 1 half is 2 times half minus 1, which is also 0. So it's right here. And f of 1/4 here I have plotted out because it's between 1/4 is between 0 and half. It gives me 1 half. So somewhere here. Um, sorry. At 1 half, I should probably include this here. Okay, this is not the function that I was thinking it is, but anyways, it still is a compound function, and depending on what the input is, you use either the first definition or you use the second definition. Okay, now we're going to use this compound function in the definition of something that we're going to learn next. I said, I ask you these questions and I ask you to answer them intuitively. How far is the number 10 from 0? Is there any other number equally far from 0? How far is negative 5 from 0? How far is 7 from 6? How far is 3 from negative 4? Try and answer these problems. And the goal is to develop a function which models the capturing of distances between points on the number line. And you can check your answers here. Well, the first one is at a distance of 10 units. Yeah. Second, yes, there's another point which is negative 10. It's also 10 distance from 0. Third one is 5 units because distance is positive. And the fourth one is 1 unit. The fifth one is 7 units. As you can see, the distance between negative 4 to 0 is 4. And the distance between 0 and 3 is 3. So add them up to get 7 units. This notion of distance is called absolute value, and the notation is 2 vertical bars. So This would read um, the absolute value of x. So absolute value of 10 can also be another way to think about it is distance of 10 from 0 is 10. Distance of negative 3 from 0 is 3. 8 minus 6, distance of 6 from 2 is distance of 2 from 0, which is 2. Now the distance of negative 5 from 4 is 9. Distance from 4 from negative 7 is 11. So concept check here, sorry, this did not scan properly, but this is saying I can write this function as a compound function in the following form. I can say this is x when x is greater than 0 and negative x when x is less than equal to 0. Question is, can you justify this definition? Why does it work or does it work? And if it does, why? Now we can flip the question and ask what are the solutions to absolute value of x equals 5? This means what values of x are distance 5 from 0? Clearly there's only 2 points, positive 5 and negative 5. So the conclusion we draw is when you get rid of the absolute value, it requires that you solve for both positive and negative value, meaning absolute value of x equals a becomes x equals a or x equals negative a, just as we saw in the example above. Or in general, absolute value of anything equals anything else means the the squiggle thing equals the mesh, or the squiggle thing equals the negative of the mesh. So the idea here is doesn't matter what these things are, but you have to getting rid of the absolute value results in two equations connected by a or. Example, 2x minus 3 equals 1. Um, so you solve 2x minus 3 equals 11, or 2x minus 3 equals negative 11. And you get two answers. Remember, alternate solution notation is this, which is using, this is set notation that we saw for domain and range in chapter 1. You can also have variables in both. In that case, you go 3x minus 1 equals x plus 5 and 3x minus 1 equals negative x plus 5. Careful with the distribution of the negative. You go ahead and solve these as regular equations. Sorry, the answer has been cut off here, but this gives you x equals 3 and this gives you x equals negative 1. So you may want to try this out on your own and verify the answers, and then you can check your steps. Well, now that you've done equality, we can ask about inequality. Absolute value inequality is a culmination of all we have covered so far. It brings together inequality, absolute value, compound functions, etc. Let's try to understand what this term means. Absolute value of x less than 5. In terms of distance, it means the values of x such that the distance of x from 0 is less than 5. What are those values? Well, everything between 0 and 5 clearly has a distance less than 5, and then so does everything between 0 and negative 5. So as long as x is in this green red-ish region, this is true. So the solution is negative 5 to 5, or you write it as in the compound inequality form, or you use the number line. Now the shorter method is we can rewrite the absolute value inequality as a compound inequality. Remember, absolute value of x less than 5 is the same as negative 5 less than x less than 5. You can check that the direction is preserved. So it's going to the left, that's why everything is to the left. If it's greater than, everything is going to the right, so you rewrite it as going to the right. The direction of the sign remains consistent. This works in general too, meaning it can be anything. It doesn't have to be x. If you have smiley face less than 7, so on, it just works. For example, x minus 4 less than equal to 3. Everything is to the left, so that's what I get. And I know how to solve this because I just add 4 and I get this intersection, and that's my result. So it boils down to what we've learned before. Few more examples. You can have complicated case, negative 2 times something. So note that this is not directly in the form of, say, absolute value of squiggle greater than equal to number. So we have to transform it first. To transform it, we get rid of the 7 by subtracting 7, and then getting rid of the negative 2 by dividing it. When you divide, just be careful that the sign flips. And now this is okay. Now we can transform it. Now this can be can use the definition, meaning now this can be written as greater than negative 10 and less than 10, and it can be solved to get this region. Now x minus 2 greater than 3, this is different because it's a greater than sign. So you have x minus 2 greater than 3, less than 3. You end up with x is less than negative 1 or x is greater than 5. Which you have to use union to denote the solution set. There's another example here. You can pause the video, try it on your own, and make sure you get the same answer set. So that's the end of the topics